So this is a disclaimer. So this content is everything belongs to us. Uh, Nothing to, you should not take this note and you should not recreate and everything from this content. So do the disclaimer we given that. And then yeah, today we are going to learn something about the cooling coil valve sizing actually. So the purpose of the cooling coil control. So before entering into that control valve sizing, we just understand little bit tips about the purpose of cooling coil control. Obviously, cooling coil means it is going to something going to control the temperature, like maintaining desired temperature by passing the cooling water into the coil, and then it is controlling the entire temperature because air is passing to the cooling coil, entering into the cooling coil, leaving time. The air will be getting cooled. But in that cooling coil, have you ever noticed there is two type of flow? There is mentioned that one is that parallel flow, another one is the counter flow. So two kind of flow. Let me explain that. The first one is the counter flow. So counter flow and second one is the parallel flow. Look at this images. You can see this. These two images are look like same. But what is the different in this counter flow and then parallel flow? Like if you look at here, so air is going like this and coming in this way. Same here also air is entering and coming in this way. It means no different. The terminology saying that different. Only you can differentiate that entering water on the bottom side and leaving water on the top side. And here entering water on the top side and leaving water on the bottom side. You can see that much different. But if you in depth look at this cooling coil, see this. So in this portion, this is in the right side. This is the cooling coil. So this is a cooling coil. You have two sides, one right side and left side. So in this side, if you're entering the water, it will go inside the coil and then it will come back to this. It will come back to this in this side. So leaving water side this side actually. So which means entering side is in the right side. Cooling water entering side is the right side. Hot water in the leaving water, little bit hot water in the left side. But this is known as a counter flow. But in the parallel flow, the entering water in the left side actually, it will be in the left side. See, look at side, left side, and then it will go in. It will come like this. So water come in the right side, which means when the air is passing into that coil, first in the counter flow first it will face the leaving water coil, and after passing this cooling coil it will face the entering water, that is chill water. So here you will see that in this counter flow, uh, first hot air will come, and in this leaving water side little bit cooling will be there. It will reduce the little bit temperature, and then it will move on to that cooling coil, real cooling water entering side, and it will completely reduce the temperature, and then that final output will be a reduced temperature will go inside the duct. But in the parallel flow, first cooling water is going right, so the air will be first cool down, and then when the leaving time little bit hot water is there, so again the temperature will increase that. Minorly the temperature changes will be happen in the parallel flow. So most of the time you will be see that counter flow, but very rare case only you will see that parallel flow cooling coil. So this is know about the cooling coil. Let me take a eraser. Okay, okay, erase all. So this is known as the cooling coil. Now we want to understand that valve placement. Cooling coil have that open and entry exit that. Before the cooling coil, we will place the valve. So that valve, how we will size first. But that valve how will be placed? Actually, we will place in the supply side, which means entering water side or leaving water side. This question will come. That before going to that explanation, let me give the descriptions and everything. You can take a notes of the thing, whatever I explained in the previous slide. So that definition is given here. So that is the counterflow. It have that living. You can see that example I just mentioned, that airflow will be left to right and water flow will be right to left. This is known as a counterflow. And what will be the effect? This kind of basic definitions and the impact is given, that you can take a snap or something. And so same for parallel flow. You can take a snap or notes something for this. Okay, I'm just assuming that you have done that snap something. Let's move on to that valve placement, because valve placement is the very important. Where which side you are placing that, whether you are placing in the supply side before the coil or return line. That mostly in the general common sense, we will say that obviously we have to place in the return side, because the cooling coil has to be filled with water. Because before placing in the cooling coil, mean when the valve is not using, there is no flow at the coil, and the demand is generated by the HU system, and suddenly the supply side valve is opening and the coil has to fill the water. It will take some time. This is also energy waste, right? Actually, so most of the time, the recommended thing, valve has to be placed in the return line, because it is very important at the time of designing time also, when you are preparing the control submittal. So in that control submittal, we are showcasing that flow diagram of the cooling coil, where you are placing it, is placing in the supply line or return line. Recommended is return line, because it will fill the cooling coil water completely, and because there is always be a little bit pressure required for the better controllability. Because if place the valve before the supply line, before the coil, then the pressure build will take some time, and that time it will be, the temperature will increase. That some few minutes also it will impact a lot of energies actually. So recommendation is, major recommendation, it has to fill, the water has to fill with the cooling coil, and it has to place in the return line, valve has to place in the return line. And again, some of the mechanical contractor, there is they are recommending to place in the supply line, but those things are, you have to be conformed in the MEP drawing, mechanical electrical plumbing drawing. We will show that example, that realistic example also after this slides actually, after while sizing the AHU cooling coil valve. Okay, so next slide. So coming into that quick design uh, tip actually. So that is the AHU cooling valve sizing, because we are going to look at the lot of parameters. We are going to look at that. Each of the things are definitions only. Each definitions will give you a importance of AHU valve sizing actually. So please be careful on that each definitions, and understand the definition. And meanwhile, we will show the practically that definitions are how impacting at the time of valve sizing. Practical example will show that, and also will show that graphics, 3D graphics for you at the end of the session. You can see that those kind of things. Okay. First, why are the valves are required? Why are the valves are required? So that is very important question actually. You can you have chiller system and you have pump, and pump is pushing the water. You can directly send the water to cooling coil and take the return water into the chiller, and you can do this loop, continuous loop, without installing valve. But why it is required? See, first thing is, you have to understand that AHU is majorly working on based on the number of zone is actively occupied. So how many zones are occupied? What is the demand? Based on the demand, AHU speed ramp up, the fan speed will ramp up and ramp down. and accordingly VAVs are serving actually. So when the demand is in the multiple zone and the temperature is has to maintain the human comfort level, so in that time the cooling has to be regulate the flow. If there is a no demand, we can just park that, we can just hold that water. If there is a demand, we can regulate the water flow, which means if you are controlling the flow, by controlling the flow, you are maintaining the desired temperature conditions for the particular zone or a particular area of the building. And purpose is the control valves are majorly controlled by giving the some reference uh, temperature and reference set point, which is has been processed in the PID loop actually. Those are the programming element. We don't need to go in deep dive. Just understand that the temperature based the control signal has to given to that particular valve, and accordingly it is going to control the entire flow. So now we'll look at that. What are the signals are required for the control valve? So if you look at here, we have a three different kind of signals actually. DDC will give that. First one is on off type signal, which means fully open or fully closed operation. And second one is floating, that is incremental. It will give the pulse type of signal, open, small kind of signal. So that one type of signal type it is given from the DDC. And third one is the modulating. So three different kind of signal. Majorly in the market, we are using the on-off and modulating type. Actually, two is majorly playing a predominant role. Floating, it's a budget-friendly zone valves are. Nowadays, it is absoluting that. But you just think about when you are valve sizing while looking at the MEP drawing. So, which type signal is this AHU system is demanding to us? So that signal type you have to identify from the MEP drawing. We will see in that practical exam. And second thing, the first point, this one, which signal type you have to uh, demanding that system, that you have to identify that first condition. Second, valve type actually. Valve type means we know that the signal type is we understand from the MEP drawing it is a modulating or on off type. We understand that, but what is the type? What is the valve pattern? It is a two-way or three-way, that we have to collect the information from the MEP drawing. And then after collecting the information, so here we are going to size the valve for the AHU equipment. For the AHU equipment, what kind of valve we have to provide there? Because in the market we have the different kind of valves are there: valve, globe valve, butterfly valves, or PAC valves. But I don't know how to configure, how to choose which valve for which equipment. In a simple way, I can recommend that, I can say that terminal equipment. What are all the terminal equipment like VAVs, FCUs, unit ventilators, unit heaters, AHUs, small kind of AHUs also up to 2-inch pipe size. So you can use for ball valve or zone valves. If you are going for plant system like boiler, the chiller, heat exchanger systems, so in that time you can go for the butterfly valve or globe valve or flange type valves. So these are the things you have to first clarify. You got differentiate yourself actually. These tips will be helpful for you and properly fix your mind. Terminal equipment means as a default we have to go with the ball valve. Why? If they ask, up to 2-inch only maximum the terminal equipment pipe size will be there. It is not going to be more water flow going to happen in the cooling coil. Maximum 2-inch. So in that time we can go with the small size of valve. It will give the precise control and budget friendly also. In the AHU system, we are going to install the global means the budget will be huge. So in that case, we could not. The customer will be asked the question why could not able to achieve in the little bit more budget friendly valves. Why could not able to achieve the valve? So they can ask that. But this information where I can get that? That you can get from the specification or the scope requirement actually. So this you have to be very clear on the things. But as a simple point of view, I just recommend that thermal equipment means go with the barrel valve. Plant equipment means you just go with the flange, butterfly, or globe valves. We will see that. We will see the catalog. We will select the one valve part number properly, and we will give that. Realistically, we will see that. So in the general guideline, up to 2 inch you can use for threaded type ball valves. For larger than 2 inch, you can go with the flange type valve. In the specification, you can take that requirement. Our customers will give the requirement which is on that. Okay. Next, now very important thing is the flow units for the valve sizing. See if it is in the MEP drawing, we will see that if your valve is come up with the water or glycol mixed, you can see that the unit will be the GPM. So in the GPM, see, look at here. If it is a steam application, your unit will be this LBS power or MBH. Please be remember these things. These are the key elements actually. Now let me move to that next one. So coming into the practical thing, uh, how to identify this signal type and how to identify this valve pattern. So this question will arise on you. Here is the tips for you. You can get this information while reading the sequence of operation. I will show the document, or you can see that controls details of the a particular equipment. You can see that you can identify the patterns, or you can see that particular equipment schedule, or you can see from the IO point list, or you can see from the flow diagram. So how to identify that these are the five elements only repeatedly following for all the people. Other than five, nothing is. In this five, minimum two if you refer, you can able to easily identify that which control signal is required, which valve pattern is required, and then which type of uh, like feedback is required or not. So this kind of information you will easily gather from these things. And then body type, which material has to use, this will be you will get from the specification sheet. Okay. So let me show that real-time example for you for the AHU application. Before entering to that, we will see that real-time example for this thing. So this is a MEP document, mechanical electric plumbing document. In this index of drawing, you will see that there is plumbing drawings there is a mechanical drawing is there, and then there is electrical drawing is there. So our major focus has to be in the mechanical and then plumbing, because we're going to deal the valve sizing part, especially we need a pipe size, so we have to look at mechanical and plumbing drawings actually. So let me look at this. In this mechanical, I just want to first locate the AHU equipment, because our title is AHU. So let me find the AHU in this document. Let me scroll down. So AHU will be in the schedule, mechanical schedule. Okay, this is the mechanical schedule for this building. So what are all the equipments are uh, present in this building? So this mechanical schedule will teach you that. Uh, so here we have the list of equipment like chill water, air handling unit, air cool chiller, VAVs, and then fan schedule, lower schedule, ductless split system. Everything is there. We are going to look at today is AHU, AHU1. Okay, and then AHU2, AHU3 you have to practice. Okay, so I will give the assignment and later you can do that. So in this, if you look at this equipment schedule, so first we have to locate the cooling coil. So in this AHU schedule, first we have to locate the cooling coil title first. So cooling coil title here, I can able to see this here, the cooling coil. Yeah. So in this cooling coil, the fluid type they mentioned that it is chilled water. And then next you have to what, you have to look at that GPM, the code word. That is the secret thing. Look at the chilled water GPM water flow. So it is given as a 78.6. See, and then I will come to this thing before explaining to that. And but we want to look at that identifying the signal type, and we want to look at the valve pattern. So for this AHU1, we have to look at this cooling coil. This have the cooling coil. We have to look at the signal type, and then we have to look at the valve pattern. So first, in order to identify the valve pattern, we have to go to that cooling coil mechanical details drawing. So let me search that mechanical details drawing in this MEP document. See, this is the mechanical details drawing. If you look at here, there is list of equipment, each sensor, each equipment hanging, all the details they will give in depth actually. In that detailed section, you have to locate that our equipment. Already I have located for the time consuming purpose. So here piping at the cooling coil, it is clearly state that two-way valve, but we will confirm in the drawing also. If you look at this drawing, here it is a complete cooling coil drawing actually. So in this is a supply line and this is a return line. So then the return line they given a two-way control valve. See, and did you notice that this cooling coil pattern counter flow or parallel flow? See, look at this is in the where supply water is entering in the left side, which means it is a parallel flow. So return water is entering in this side. Sorry, I just forgot that the airflow direction. So the airflow direction in this side actually. So hot water is first here. That means leaving water is here, and then chill water is here, which means it is a counterflow, which means it is a very energy efficiency. Let me show in the PPT also what I'm talking about that. Yeah, this is talk about this counterflow, which means in the leaving air side, if the cooling coil is present, then you have the more energy efficiency. So same thing in the given in the document also. This is counterflow, and the cooling oils is placed in the return line, and it is a two-way control valve. Now next we understand that valve pattern, but what about the signal type actually? It is a modulating or it is a on off, we don't know. Still now there is no much information. So next thing what I told that we have to look at the sequence of operation or IO point schedule or in the flow diagram. So let me identify in this drawing where is the controls details are given that. So I can able to see this. After the schedule they given the control details. So mechanical controls details, if you look at here, mechanical controls details they given that. So in this controls detail, sequence of operation for variable volume AHU we are handling. It is a typical for other AHUs also. This is a sequence of operation. In this sequence of operation, uh, we have to locate the cooling coil portion. Where is the cooling coil portion actually? When you are sizing for complete material while doing the estimation design, we will completely read that, but we are focusing for today cooling coil valve sizing. So let's focus on where is the cooling coil. The headlines we have to look at that. Ventilation air cooling mode. Yeah, here we have the cooling mode. If you read the sequence of operation, cooling coil control valve shall be controlled by a control loop with the coil leaving air temperature transmitter as the input and the set point equal to the 52 degree Fahrenheit. And TTCAT, which means leaving coil air temperature, shall alarm the DDC system whenever the coil leaving air temperature is too high or low. So it is talking about controlling also and high and low alarm also. If you look at the first line, the cooling coil control valve shall be controlled by a control loop. Loop means it will not end. So continuously it will happen, which means it is not stating that open or close. It is loop means 0 to 100 modulation. The loop will be go 100 to 0 or 0 to 100. Keep on, it will go there. So here they are stating that modulating, but still I am not convincing with this word. Only the loop only directly stating that meaning of modulation. Let me look at that in the IO point list, which is given nearest that. So in this IO point list, any information or evidence are giving or not. If you look at here, the chilled water valve, VCHO, and just given a drag line here, and it is stating that in this dot is in the vertically. If I look at here, it is analog and valve position. It is a valve position and it is an input, which means we are targeting that this valve's modulating or it's a open close. In that time we got that information, one information. It is a feedback is required. That's analog input, which means it is going to be a modulating only. Again, we want to check the evidence. We want to collect the evidence. Still, I'm going to dragging to identify the information. The dot is stopped here. And if you look at here, valve position at the output, it is given as an analog, which means the valve output is analog. So in the sequence of operation stating that is a control loop, and we are assuming it's a modulating, and the IO points also stating that it is an analog type, then it is a modulating only, and it have the feedback also, which means we have to choose the valve along with the feedback. So still now, is it clear, right? So we started with we need a AHU valve, and we started with look at the MEP drawing. We locate the AHU schedule, equipment schedule. In that we look at the cooling coil portion. We understand the what type of medium, water medium, and later on that we look at the detailed drawing. We understand the valve pattern. It's a two-way or three-way. It's a two-way only. And after that we come to that sequence of operation IO point schedule. We conclude that it is a two-way modulating valve. Till that time, till that area, we come to conclusion. Then what is the next actually? What is the next? We have to again double check with the flow diagram, because all the time the MEP drawing will not, all the three will not come. Any two, any one only will come. So I have, as a training purpose, I have shown all the possible inputs, so it will helpful to you can locate in somewhere. If you get the sequence of operation, you can decode that. So if you look at here, chiller cooling water. So here they given us a chilled water control valve as a AO and AI. So which means it's a modulating, and here they given a two-way. Everything is given a single triangle. So we have now clear idea two-way modulating valve. Now what is next actually? So we have to size the correct valve, right? So for that, what required? Let me enter into that PPT. Okay, till that time we came to here. Now we have identifying the signal type and valve control type. Using this five method, we come to some conclusion that what type of valve required. Now next is the calculation, the crucial part actually, the calculation. Okay, valve sizing. So be steady with yourself actually. So valve sizing, after identifying that signal type and valve pattern and all, so what will be the next actually? So we need a flow. First thing is flow, water flow. How much water flow going inside the pipe actually? Whether it will be a water or glycol mixed water, or it is a steam or something. Today we are going to look at the cooling coil between chilled water only. So GPM we are going to locate that. And next one is the pressure. What is pressure? Sometimes the pressure units you can easily locate that via they will mention that water pressure difference in the PSI or in the feet of head. In that type they will, in the units type they will mention that. I will explain. And then next you have to look at the line size, which means pipe size. Line size also you can tell that, or pipe size. And fourth one is the specification. What is the valve type requirement? Whether it is a brass body valve required, or it's a stainless steel type a stem is required, or it is has to be a ball valve only, or it has to be a globe. All these kind of requirements they will mention in the specifications actually. So here we, if it is a steam application, mean majorly they will require for the stainless steel type material. Here we are going to size the cooling valve, so brass material is enough. Let's look at the first three informations actually, like GPM, how much GPM, what is the pressure, and what is the line size. We'll locate in the drawing actually, and we will see the practically how it is going to the pressure is and GPM is how helping to size the valve. Let me open this drawing. Let me go into the schedule actually. So here we have located a GPM, which means 78.6 actually. In your note, just note down those other parameters also, 56.2, 54. Complex one, I will take that. And this two parameters also, you just note on that for your practice purpose. And then water pressure. Water PD means pressure difference. The unit is given in the FT. Here they sometimes they will give in the PSI, sometimes they will give in the FT. You have to convert the pressure from the FT, which means head per feet, to PSI. You have to convert that. I will explain that conversion part also. Okay, so here they given us a 8.9. Okay, so these two informations we have collected that. But next one is what is the important information? The pipeline size actually. How much line size, pipe size is going inside the coil. That information we need that, because without pipe size, using this GPM and pressure, we can calculate that. But in the catalog, we have to locate that valve pipe size also to have to match that. For example, the pipe size given in the 3 inches or 5 inches, we choose an accord the calculations at 2 inches mean, and 3-inch different will be there, pipe size to valve size. So I will explain in the 3D dimensional time. I will tell that in the end of the session. You can see that 3-dimensional graphics thing. So we have collected this GPM and pressure difference, and let's move on to that pipe size. And this pipe size we can able to collect from the plumbing drawing. So here we have the AHU1 actually. Let me search the plumbing drawing where it is the AHU1 is located. So okay, first floor HVAC piping. I'll start from the first floor. This is duct. This is duct drawing. This is a plumbing drawing. I just want to locate the AHU1. If you zoom it, AHU left to right. If I read this here, I have AHU1. This square box is known as the AHU1. And then in this AHU, the cooling coil line it is coming. The chill water system is supplying this water here, and it is coming here. And then in this chill water, this line, this, if you look at this arrow, this is chill water supply, is going to supply. And then this line, it is a chilled water return. In this circle they given this is a joint given to this AHU cooling coil. This circle is known as the joining to this cooling coil. So which means the chill water supply and return, and near tag is given, and the near to tag, if you look at, yes, 3 inches. The pipe size is 3 inches to the cooling coil. So we have collected now pipe size also. We have now GPM. We have now pressure. Now what is next actually? It is a calculation. So let's move on to the calculation. So pressure drop actually. So previously in the equipment schedule you saw that there is a pressure drop actually. So majorly pressure drop is there is lot of uh, informations are in the pressure drop actually. Entire pipe circuit around the cooling coil have some pressure drop. In the valve, inside the valve, there is some pressure drop. So which pressure drop we are going to take that? For in order to size the valve, we are going to take the inside the valve pressure, because if the water flow is coming and the valve can able to handle that pressurized water flow, then it will give the good control, stability control. If it could not able to maintain or resist or hold that pressure, then obviously water leak will happen at the pipe. If you undersize or if you oversize, it will give the unnecessary pressure to the pumping side. So let's see that here we just has to only focus on the pressure drop at the valve. So that is known as the delta P, which is difference between the inlet and outlet pressure of the valve. So what is inlet and outlet pressure of the valve? Let me show that the animation. I think we have that animation here. Let me show that animation for you. Okay, give me 1 minute. I'm just adjusting that. Okay. Let me play the animation so you can able to easily understand that. So the water is coming. So if you look at here, the water is coming and the valve is closed. So this, whenever we are sizing this valve have a capability to hold this water, which means if the pressure is high, if you're undersize the valve, the leakage will happen. It will flow outside this pipe because this pipe is connected to this valve. The leakage will happen. If you use oversized, the flow will more. The pump will get put a more energy to push the water inside that piping system. So due to that, we have to size the accurate valve. So in this, water is coming. It will come along with the some pressure that is known as the inlet pressure. Before the valve, it is known as inside. We entering into that side, it is known as the inlet pressure. And then when the valve is open, water is going outside. That is known as the outlet pressure. Outlet pressure. This is inlet pressure. So inlet have some 10 psi means outlet obviously will have some reduced pressure because the valve inside the valve it is slowly open. That valve mouth will be little bit lower than the pipe size, and inside the mode the flow will be reduced, obviously the pressure will be reduced, the volume will, if it is reduced, obviously that pressure also will reduce that. So the difference between inlet and outlet, that is considered as a P1 and it is considered as a P2. Difference between P1 and P2, it is known as the delta pressure. It is known as the pressure drop at the valve. So let me show this animation. So water is coming, the pump is pushing the water, and water is coming and hitting the valve, and valve is opening that with the help of the actuator. Now water is going. See, the water is coming with the full pressure, and the valve is fully open, and a small amount of water slowly it will pick up that, and in a certain range it will have some reduced pressure due to the resistance of the valve material and valve body. The keyword is resistant. Someone is giving the pressure and you are using that valve resisting that pressure, it will indirectly reduce the water pressure. So that resistance generating that pressure, right, that is known as the effective pressure of the valve. Simply you can tell that in the formula, if they ask the delta pressure means the valve pressure at the valve, the pressure at the valve, which means the pressure will be happen in the portion. Here on X pressure will be there, here Y pressure will be there. This difference is how much is that? That is known as the effective pressure at the valve or differential pressure at the valve. Any kind of words you can use that. So remember this simulations in your mind actually. So it will help you to recollect that inlet pressure minus outlet pressure. It is known as the differential pressure at the valve. So this operation will be happen with the help of actuator. So here what we are going to size that using the formula in the catalog, we are going to choose that we will choose the valve body. See this valve body, complete valve body. Let me choose in the green color. If you look at here, this is the valve body, or you can show in the early space. If you look at here, this is the valve body. Let me take a pen. This valve body we will choose that, along with we will choose the actuators also. So if you look at here, the thread, the teeth is there, right? This is known as the threaded type valve. And if you look at here, disc, just example purpose, we created this animation. Look at here, disk. Let me little bit move forward this. Look at here, the disk. That is all. This disk type. Pipe is, this is a pipe. This is a pipe and it is connected to the valve. Training purpose, we made two things in a single thing. Threaded type is here and the flange type is there. The disk type known as a flange. Here the nuts are connected. The bolt. Here it is a threaded type. But practically threaded type valve means both the side thread will be there. So don't bother about that. And we will choose this valve body. Along with that, we will choose the preferable actuator for these things, this valve. So entire system will be like this because this valve body have some stem. This stem is connected to this actuator. So this actuator is rotate the stem, then this valve body rotate. I will show this animation once again so you can recollect that. Wait a minute. Because if you understand this core thing, then only you can able to visualize that. Just doing a visualize. So it is rotating that. So it is rotate. Rotate when will happen? When we are giving the signal from the DDC, this valve will be rotate, and after rotating, the water will flow that. So this rotation will be taken care by this actuator. This actuator. the power supply is given. It is going to connect this thing, and that water holded by this valve body. So two parts going to we are going to select that. So we just has to you have to be very careful on these things actually. So if you can able to visualize that then you can easily size the valve. Valve size is in 5 minutes we can able to do that. So valve along with actuator we have to choose that. Now let's move on to that real calculation. Let me show that calculation. Where is the calculation? Yeah. So we talk about the pressure drop, inlet and outlet difference is known as the pressure drop. And then next one is we talk about that valve body type and then actuator. We will choose this in the real catalog. Any one model like Johnson Control or Belimo or Honeywell, we will choose any one valve actually based on the calculation. And this is a simple sizing notes. If you could not able to locate the pipe size of the particular system, just for the reference purpose, up to 40 GPM, it will be 2 inch up to uh, 41 to 90 GPM, it will be 2.5 inch. If there is no line size is given, pipe size is not given, you have to remember that thing. And if it is a 3 inch mean 90 to 150 GPM and 4 inch mean 150 to 250 GPM, we can expect in that coil. That is the maximum capacity. You can expect that just for the idea purpose only. We could not able to locate the pipe size. And next one is CV, because using the CV only we are going to choose the right valve here actually. So you have the lot of definitions available in the net actually. Valve coefficient is the flow capability, control the valve, fully open condition at the 60 degree temperature and 1 psi pressure, blah blah blah. Forgot about, don't bother about the thing. Ultimately our goal is we have to identify the CV, because using the CV we can able to select the valve from the catalog actually. So without CV we could not able to select the valve from the catalog, so we need a CV. In order to calculate the CV, what are the informations are required? Simple. CV equal to Q into root of G divided by root of delta P. So Q here reference in GPM, water flow GPM. Specific gravity of the fluid is considered as a 1, so always 1, so you don't need to bother about this thing. And delta P, just now we saw that inlet and outlet pressure difference, and we already have in the our equipment schedule, which means in the look at this MEP drawing. So we have the GPM, we have the pressure difference. So just we have to put this in a formula, and then we will get the CV. But here one thing is, it is stated in the PSI. We got in the head pressure. So we just want to convert that PSI into head pressure. So let me convert in a online actually. Let me open the Edge, Google Chrome Edge. Okay. And then PSI head to FT to PSI. FT to PSI. I'm just sharing my screen for easy understanding. Okay, I put FT to PSI and I got this conversion formula. Here I'm just going 8.9. Our pressure difference is 8.9. I'm just converting. It is a 3.8 PSI. So now I just want to going to do that basic Excel, so you can easily put all this formula in a single sheet actually. So you can able to easily calculate the CV. Let me present my Excel sheet also. Okay, so can you able to see my Excel sheet? Just loading. Yeah, got it. So now I'm just going to calculate CV. CV formula. I need a CV. Let me put first GPM. It is 78.6, And next one is water pressure, pressure drop. It's 8.9. We converted. What is the conversion value? We converted it from feet to PSI. It is known as a 3.85. So let me put that 3.85. Okay. Now CV formula, we know that. What is the CV formula? Q divided by root of delta P, which means our Q equal to Q GPM divided by square root of, what is the number? 3.85. So now you got the CV. So I have GPM, we have a GPM, we have the pressure difference in PSI. Now the CV value is 40. Okay. So using this 40, this is a requirement for the valve. So we need a the valve flow coefficient is 40, because 40 range valve, if you selected, it will give the good control. If you choose less than 40, then it will be a problem. And what is the line size? That is pipe size. We have a pipe size is 3 inches. So let's go into that realistic valve selection. Actually, I will recommend, uh, I'm just going to choose that Johnson control valve using this parameter. So let me search that. Okay, Johnson control valve. We already told that it's a terminal equipment. We can go for the valve. So valve catalog. Everything is practical. The same way all the controls contractor are doing that in the same way. Nothing is different. No need to bother about that thing. So we have to locate the valve. V1000 series is valve. 1000 series valve. I'm just selecting this. I'm just opening the catalog. So here we just first look at this. Let me pull down the big screen. First read the description actually. So why I'm saying that, there is one meaning is there. If the this valve doesn't support for that particular application, there is no point of you selecting this value when you find the CV. So here VG1000 series valve closely matches your exact application requirement, and it is a most industry most complete product line. The valve is primarily designed to regulate the flow of hot water, chilled water, and 50-50 glycol solution. Our water medium is chilled water, and this is primarily designed for chilled water also. So which means we are in the right position actually. And next one is, if you look at here, this is a flange ball wall. We told that more than 2 inch in that time we can go for the flange type ball wall, but our line size is 3 inches actually. So in this 3 inches, our case is more than 2.5 inches ranges. So we have selected the flange type, disc type valve, not threaded type, disc type. Look at here, flange is screw nut type actually. So here if you scroll down that, you can see the selection chart. In this selection chart, you can see the valve size in inches. This is valve size in inches, and here they given a CV, and this is a characterized size of thing, and the close of pressure of the valve. And then here they stated this power type, ACDC 24, because 120 volts valves are available. And here if you look at here, it have that on off type, and it is a on off floating proportional. Three things are given in the here, and it is a without switches type, and it is a with switches. Without switches, with switches meaning here the valve have the open and close position will be interlocked with the sometimes with the pump. So in that case, we need additional open close end switches. So that cases we will use this auxiliary switches. Here in our case, we are not going any interlock and anything. We need a without switches also, but we need our sized CV. What is our sized CV? It's a 40. And here look at the CV, the first starting valve, and one important thing is the pattern, valve pattern, two-way. We need a two-way valve. Sometimes three-way valve by mistakenly they'll choose that. So CV here is for us required 40, and here the catalog, the manufacturer catalog, the available valve in the 47, which means our design requirement more than seven size higher, seven sizes higher, which means 40 is requirement. 47 is available means you can go that. You should not go below the 40. You can go above the 40. Below the 40, you should not go that. Above the 40 means the first size is 47. You can directly take that, and then valve size is here given 2.5 inch, so which means our pipe size is 3 inches and here available size is 2.5 inches, and they can put the reducer in between the valve from 3 inches to 2.5 inches. It will take care of that, which means 47 CV 2.5 inch valve. Our recommended, the manufacturer is recommending is available, we can choose this valve. And one more thing, here they given a valve part number and all. Here they given a three option plus 920 HGA. They given that. What is that meaning actually? Here they 920 HGA meaning here. It is a stating on off floating proportional. Three things will be happen in this thing in this 920 HGA series. If you go for different wall, I will show the different between this number and then another number for example purpose. Okay, this is also flange wall. Let me find that wall catalog. That is loading. This is a complete valve catalog, 590 pages actually. See here we have to look at that as threaded pressure zone. Yeah, I'm just finding the clear cut example to you so it will be helpful to understand properly. Okay, we need a threaded valve, threaded, not flange type, forged brass valve. If you look at here, the valve code they given, valve sizes they given, and CV they given. Here they given three different area. On off type means the code will be a 94 AGA. If it is on off without floating type means timing out type means the code will be 94 IGA. If it is a 0 to 10 volt means the same code 94 GGA, which means there each last three codes they are stating that the meaning of the function. In our case, HGA means it is a combination of three. You can configure anything. This is the difference. So here we are going to choose that we need a proportional type. It have an option of three things. On off type is you can configure that. Floating also you can configure that. You can configure proportional. So we need a this model without switches. So this is the part number for this valve. Now coming into that valve, we have chosen the valve and the signal type. What about the actuator? So here, if you look at here, the actuators they given VA9320HGA2 actuator. This is the actuator for this product. So when you are preparing the bill of material, you have to give these two part numbers, or you have to, if you are preparing the valve schedule, you have to mention this actuator part number, both the things. So valve schedules are, we I will tell that we have detailed training on the things, but key understanding, note down these things. So we have a size that our calculated the CV with the based on the inputs. We opened that Johnson control. Same thing for Honeywell controls catalog. Same thing for Belimo. Same thing for Snyder Siemens. Same thing. You just has to mention that because global valve type is similar. Ball valve means all are will call ball valve only. No one call that ball valve is not as a something gray valve or sine valve. Not kind of things. Ball valve means ball valve. You have to careful on this reading this informations. That is very very important. So we located this thing. We collected this information. We need a 3 inch or one size, two size down size valve. Here it is available 47 CV. You can able to control that. So we collected this part number. This is the final part number. And coming into that, this part number you have to take and mention in your Excel, and you have to collect this actuator part number also. You have to mention in your thing. This is for AHU1, right? So already you have taken this valve part, actuator part, right? So now you have that information from quantity. How much quantity? Obviously only one cooling coil, one AHU, one cooling coil, quantity one. So this is the preparing that you're have to create this valve. You have to size the valve like this actually, but there is a proper valve schedule that will be there actually. Using that valve information, what are the things you have to put in the valve schedule, that things available, that is a detailed training. I will tell that. Next we will go on to that valve authority, that most important thing actually. You have a size in the valve as per the CV, but your valve authority is one of the major playing the role in this valve sizing. A valve authority is nothing but stabilizing the control. If the valve authority is less than particular range, the control will be worsen actually. If the high range wind means it will give the pressure to the pump side. Here I just given a recommended, which is a ASHRAE standard recommended. If you are choosing the modulating control valve means the ranges has to be the valve authority 0.3 to 0.5, and if it is on off position means less than 0.3 acceptable. Perfect linear control theoretically only, but practically 0.3 to 0.5. Perfect linear control they given 0.5 to 0.7. This here in how to calculate the valve authority for this sized valve. Here they given that the valve authority will be calculated from the valve pressure at the pressure drop at the valve, pressure drop at the entire system. Here they given the formula is authority how to calculate pressure drop at the valve, pressure drop at the entire system excluding valve. That's summation. So which means here we have the pressure drop already. It is known as a 3.85. And then what is the summation of pressure system? Which means you have to identify the system pressure. How can I identify the system pressure? Which is you can get from the head pressure, you can get from the pressure from the pump cut sheet, pump equipment cut sheet, or you can get from the uh, chiller side head pressure near to the whichever the pump is they are placing, that pressure you can get that. But those are things informations are very rarely we will get that. As a design point of view, 30 to 35 percentage you have to take from the current pressure drop at the valve. This means, so which means here we have get the 3.85 means, let me pull the calculator here. Let me show that pressure drop is here 3.85. Our system pressure should be multiplication of 35 percentage, which means 1.35. So which means your entire circuit will be around 5 psi. So now the valve authority formula here pressure drop at the valve divided by summation of pressure drop at the valve plus total system pressure, which means your valve authority falling under the 0.3 to 0.5 range as per ASTRE standard, which means you have sized the good valve. So two things in the important in the valve sizing calculation. One is the CV, second one is the valve authority, and third one is that is ultimate one. Those are things are detailed one, that is for pipe pressure drop factor. So that thing is not say FP, but estimation and design point of view, it is valve authority CV, valve authority plus valve coefficient is enough. When it is going for lead green building certification, that time FP also will be matter. But we don't need to confuse in this free webinar now. So you just keep remember that KP, CV, these two things very very important. You have to calculate that. Here the calculated range is be given. So after choosing the valve, you have to make sure that valve pressure also correctly coming or not. Valve authorities ranges are correctly coming or not. It will be helpful to put in your valve information schedule. So typically recommended thing 0.25 to 0.5 for stable control. So let's look at this. So now remember all the things: valve coefficient, valve authority, pressure drop, and then entire circuit pressure. Here they are calling that entire circuit pressure is at the time of fully open, from the water is coming from the pump to valve, and then from the valve to it is going to cooling coil, and after the cooling coil it is returning to the pump. In this, that small portion, that circuit, that closed circuit pressure known as a system pressure. In that system things, let me show in the MEP drawing, it will be useful for you. So this circuit, in this circuit, whatever the elements are causing to drop the pressure, this is known as a system pressure drop. What are all the elements are dropping, that is here control valve only is stopping that pressure, so that is known as the pressure drop at the valve, pressure drop at the entire system. So using these two difference, they are calculating the valve authority for make suring the stabilized control. So here in this simulation you can able to understand that entire thing. So next, this is the basic method of valve sizing actually. But coming on to that steam valve sizing, heating coil valve sizing, PICV valve sizing, or coming into that detailed valve schedule information sheet prepared. We have 100 views as to how to prepare that valve schedule for the things. So those kind of things, if you are interested to learn, and the same three-dimensional training like theory, practical, and animations. For that, We are offering a design and estimation training. So this is our training model's complete practical training model. So in this training model, you will learn about all the stuff from estimation to design of the building management system.